Thank you so much for joining us today for our special Paths to Publication. We are hosting a special summer session with two esteemed speakers today. And so I would like to thank them for joining us today. And just want to remind you that Paths to Publication is normally something we do during the normal school semester. However, this particular time we have a special opportunity and we did not want anyone to miss out on that. So what we're going to do today is we have two guest speakers and each will speak for approximately 45 minutes. Then we will entertain some questions at some point during this presentation. Feel free as usual to put your questions in the chat so that we can make sure our speakers address them. In between the speakers, I will present a second biography for our second speaker, and then we will have our final presentation. So again, thank you for joining us. So I'm going to take time right now to introduce our first speaker. And our first speaker is Dr. Alan Chung, who is a professor at the Chinese University of Hong Kong and researcher at the Center for Research and Reform in Education at Johns Hopkins University. He is also a distinguished chair professor at Nanjing Normal University. His research areas include evidence-based reform, bilingual education, and educational technology. He has been involved in many large-scale randomized experiments and studies in these topics and is the author and co-author of numerous journal articles, book chapters, and technical reports. His journal articles have appeared in top academic journals such as Review of Education, Review of Educational Research, Educational Research Review, Journal of Educational Psychology, American Educational Research Journal, and Reading Research Quarterly. He has also received 3 prestigious awards for research: the Palmer O. Johnson Award for the best article published in an AERA journal by the American Educational Research Association, and the Research Excellence Award and the International Discovery Award by the Australian Research Council. In 2016, he also received an Outstanding Alumni Achievement Award from Brigham Young University, his alma mater, to recognize his significant contributions to his profession and community. I would like to take this time to thank Dr. Chung for being here, and I will let him now share his screen.
Well, thank you. It's good to be at Texas A&M. I think it's about 100 degrees outside, but it's at least dry. It's not as humid as in Hong Kong. Well, thanks, Beverly, Raphael, and Puhe for the invitation. And it's also good to be with my colleagues at Hopkins, Steve, with me today. Today, I'll be spending probably the next 30 minutes or so to talk about a rather interesting and important issue in educational research, which is how methodological features affect effect sizes. As many of you know, evidence has been playing a very important role in educational policy. For example, ESSA specify levels of evidence that must be achieved to qualify certain grants. And there have been major synthesis efforts in education in the US. Many of you are very familiar, right? Walker House, and at Hopkins, we have a center called Center for Research and Reform in Education. In the UK, there's a center called Evidence for Policy and Practice Information and Coordination Center. In Asia, our university, as well as Nanjing Normal University, have been joining this effort in the past few years. Well, another one is we also have been working with Hopkins and other institutions to produce what we call bi-weekly best evidence in brief to frontline teacher as well as a practitioner in the field. Well, as evidence become increasingly important in educational policy, I think it's quite important to understand how research designs or methodological feature might contribute to the reported effect sizes in experiments evaluating educational programs. Now, the two questions we try to answer is, what are some of the relationships between a methodological feature and effect sizes? And the second one is, how do you define a, effect size, whether it's a small, medium, or large? Now, for those who may not feel familiar with the term effect size, effect size is basically simply a way of quantifying the effectiveness of a particular intervention, relative to some traditional comparison intervention. Effect size is basically subtract the mean of the control by, the mean of experimental group and divided by the standard deviation. For example, let's say we're doing a randomized, study, right? 30 students in a treatment and 30 in a control group. You try to see the effectiveness of a, innovative program that, intend to improve, IQ of your students. After a year implementation, the treatment group got a 108, per test score, whereas, the control group 104, right? The effect size is, very simple, 108 minus 104 divided by the standard deviation of IQ, which is 16 or 15. You got a quarter of standard deviation. Now, there's, many ways you can interpret, this effect size, right? Probably one of the benchmark, most companies use a benchmark is, by Cohen, which say, if you have an effect size of 0.2, we consider small, 0.5 is medium, 0.8 is large, right? Bob Slavin argued that if you got a quarter of standard deviation, this intervention could be considered as educationally meaningful. That means you're making a difference. Now, in one of the latest research article by Matthew Kraft, by the way, he came to Hong Kong a few years ago. We have a very good conversation on this topic. In his article, he defined, if you have a study that had, 0.05 less than this, 0.05 effect size is considered small. Between 0.05 to 0.2 is medium, and larger than 0.2 is large. Now, if you look at the previous review or research synthesis in many of these, on some of these topics, interesting, there's a lot of issues with these reviews. Let me give you one example to illustrate that. Bob Slavin and I did a meta-analysis on the effectiveness of educational technology application on math achievement for K-12 children. We looked, through, hundreds of studies. In a final sample, we included 74 high quality, studies based on a sample size of 57,000, K-12 students. 45 of them were elementary studies and 29 are secondary studies. Our finding is pretty consistent with the previous reviews. That is, educational technology application generally produce a positive, though modest effect size. The effect size overall is 0.15, but it varies from, the type of intervention. For example, if you have a supplemental educational technology application, the effect size tend to be a little bit smaller as opposed to if you have a more integrated, approach in application. Now, this is, before our reviews, there have been, at least 25 previous review done on the very same topic. If you look at the effect size, overall effect size of the educational technology application on achievement, the effect size, all those effect sizes were larger than the one that we our study. Now, what we found is there's some common problems with some of these previous reviews. Here's some of the example. For example, lack of control group, and some of the study had very brief duration. Some of them could be a 1 week duration. Let me go through some of the issues. For example, if you look at the earlier review, Hartley and Burns on the same topic, a lot of them, they did not have a control group. And Liu, 1998 is another case in point. In his review, he included a total of 35 studies to examine the effects, the impact of hypermedia on student achievement. And 5 of them, were one group repeated measures without a traditional control group. Now, the finding was interesting. This is an older study, but the same principle applied. What he found was the average effect size of this 5 repeated measure study, the effect size was 1.83, almost 2, which is large, very large, and much larger than those studied with a control group. The average for those studied with a control group was only roughly about 0.18. It's a little bit 0.2, okay? You can see the huge difference between the two groups. Again, as we mentioned, the example that we mentioned, right? Without a control group, with a control group, you got 0.25, right? The example that I mentioned. Without a control group, you double the effect size, okay? Because you don't have to subtract, the difference between the two groups. Now, the second issue is a brief duration. We look at a lot of studies, many of the studies have very short duration. And what we found was shorter duration studies tend to produce larger effects than long duration studies due to novelty factors or better control environment or the likely use of, tests that bias toward, the treatment or the experimental groups. And also experimenters, those developers often create, some highly artificial conditions in brief studies that cannot be maintained for a whole school year. Let me give you one example. I've, some colleague in Concordia, they have a wonderful program called Abracadabra. One of the studies, earliest study, the duration was about 4, to 6 weeks. And they had 3, graduate students in the classroom helping the teacher. And this is what we call a very artificial condition. You cannot maintain, that condition for a school year. In real, classroom, you can have like 3 graduate students. And this is what we call the efficacy study, which generates some important information, but not very helpful in, if you look at the overall effectiveness of, this program in real life. Another example is, if you look at Kulik and Kulik, right? They, in their updated review on educational technology, they included 53 new studies, covering students from elementary school to college. However, out of these 53 added study, the new studies added to the review, over half had a duration of less than 12 weeks. And 11 of them were only 1-week experiments, which again has a much more positive, impact than the longest study. And many of the early study also show that many of the, study they included have very short duration. Third issue is we find a lot of study had, didn't show any initial equivalence. Establishing initial equivalence is of great importance in evaluating program effectiveness. Now, many studies did not report initial equivalence or use a post-test only design. Now, since, math or reading post-test were so highly correlated with pre-test, even a modest but unreported, pre-test difference can make a huge difference. Many of you heard about ceiling effect and floor effect. So you have to have, two groups comparable at the start when you, evaluating this program. Finberg once said, I think this is sum up the importance of initial equivalence. Is that it's like watching a baseball game beginning in the 5th inning. If you are not told the score from the previous innings, nothing you see can tell you who is winning the game. The fourth issue is, we found some of the study had large pretest, difference. Of course, if you have studies that have large pretest difference, it will pose, threat to validity, even you use, statistical control. So I think it's important to look at, making sure you know when you, include a study in the review or meta-analysis, making sure they have a similar baseline. The other interesting issue is we look at is the measures. The magnitude of effect size really depending on what kind of measure you use, as Kraft also argue. Now, a very frequent practice, especially in brief study of math intervention, is the use of outcome measure that are closely aligned with the content taught to the experimental group, but not in the control group. Now, if you look at that, Slavin and Madden, right, in 2002, they identified 7 math study, accepted by the Woodward Clearinghouse that reported outcome on both, treatment inheritance and treatment independent measures. Now, the effect sizes were 0.45 for treatment inheritance. If you use a treatment inheritance measure, as opposed to, treatment independent measure, the effect size was only, negative 0.03. On 10 reading study, the effect size were 0.51 and 0.06 respectively. As you can see from, this chart, you had a much larger effect size if you use, a measure that is, a treatment inheritance. So that's why it's important to look at what kind of outcome measure that you use. This is for reading. Let me give you, another example. Rochelle, 2010, evaluated a program called SimCal. There were, 7th and 8th grader, right? They were taught a 2.5-week unit on a particular, topic. There were pre and post tests on those subtests, M1 and M2. Now, M1 was designed to represent, the content taught to all students in Texas. M2 was specifically aligned to the content taught only in SimCal. The effect size, if you look at the, the PowerPoint slide, right? Effect size for M2 is 0.81, 0.89, 0.69, and 0.81. Okay. Effect size for M1 is 0.1 and 0.13 and 0.19. If you combine all that, right? So if you combine those M1 and M2, still produce a very positive, outcome, which is 0.69, 0.5, and 0.56. Now the question is, which measure count in the meta-analysis or research review? Now, if you use only M1, it will be only fair to the control group, right? But using M1, you can, probably if you use M1 measure, right, it would greatly understate the impact of SimCal. But if you don't exclude them, you overstate the average effect size. Now, if you look at, a lot of the studies, right, each study is unique. They use different outcome measures. So what kind of outcome measures are appropriate for educational research? It really depends, okay? So there are 4 types mainly. The first type is standardized tests, right? For reading, math, and science, right? You have standardized tests. And, the other one is researcher developed measures. The other one is, general tests. The last one is specific tests. Now, if you look at, these different tests, the effect size is very interesting. If you look at that, if you use a standardized test, which cover a broad topic, the mean effect size out from, this 29 studies, only less than 0.1 is 0.09. Now, if you use a standardized test that has a narrow focus, the effect size was 0.32. This is out of, 127 studies. If you have a focal topic, very focused, the effect size could reach 2.5. And this is by Lipsy, 2008. The other issue is with cherry picking. I think this is quite interesting. If you look at, this is a strategy used by some developer or vendors, right, to pick their favorite finding to support their course. Now, we look at a review, right, a Becker. They included 11 computer curriculum corporation intervention study in the review. 4 of the 11 study were carried out by the vendor. Okay, effect size, produced, was suspiciously large. Ranging from 0.6 to 1.6. And the overall effect size was roughly about 0.8. But they used a very unusual procedure to include or exclude, studies in, students in both experimental and control group. For example, they exclude those who show a sharp decline in score at the post-test, but include those who show a huge gain. So if you include those studies in the review, the adjusted effect size was only 0.35, not as big as they reported. And also the other question is I posed is, methodological feature also affects or correlate with the outcomes. I'm gonna show you a study that done by me and my colleagues. So we include all, a total of 645 studies, from 12 published, reviews, which include math, reading, science in both elementary and secondary schools, and early childhood and technology application. Now, the inclusion criteria for study is we look at pre-K to 12. And in order to be included in the study, you have to compare to a control group. You have to use a random assignment or quasi-experiment adjusted for pretest. Now, if you use measure inherited treatment, we'll exclude them. And the study duration had to, over, 12 weeks, like a semester long. And at least, 2 teachers in each treatment group. Now, what we found was very interesting. If you look at, the slide, if a study used, independent, measure, the effect size was only 0.2, as opposed to 0.4 if you use a researcher make measures. Now, this is, content that taught in both group, okay? But still, you see almost double the effect size. Now, in terms of sample size, right? If you have a large, if your study had a large sample size, that is over 250, okay, which is about 10 classrooms. The effect size, out from that 310 studies is 0.16. Whereas if you have a smaller study, small scale study, the effect size was roughly about 0.3. Again, it's almost double. Now, we also analyze, by sample size. We disaggregate the data. If you look at that, the trend is the smaller the sample size, the larger the effect size. For example, those studies with less than 100 students, we have 154 in the sample. The point estimate was 0.38. 100 to 200, 0.26. 2 to 300, 0.21. If you go down to 1,000 to 2,000, it's 0.13. Larger than 2,000 is 0.11. If you look at some of the large randomized study conducted in the past 10 years, right? You see the effect size was not that great. We have a team here, we're working. It's just very difficult to get a huge effect size. Okay, if you get a 0.2, you'll be very happy, right, Raphael? Right? So anyway, in terms of research design, if you had you conduct a quasi experiment, the effect size was roughly 0.23, a quarter of standard deviation. Whereas you use a randomized study, experimental design is 0.16. Okay. We also control for let me show you this. We also combine the sample size and the research design. Again, we see a similar pattern. If you have a large, sample, the effect size is, smaller, almost half of the effect size compared to a small scale study. In terms of elementary, there's not much of a difference, a little bit, not a lot, okay? In terms of published and unpublished, published study tend to have a, larger, effect size 0.3, unpublished is about 0.16. You all heard of, the term, file draw effect. We also run a meta regression and control for all the variables. So again, we see the similar pattern. So what is the large effect size? It really depends, depending on, the sample size, depending on what type of, outcome measures you use, right? But roughly, if you running a large randomized study, if your effect size larger than 0.12, that's above average. If it's a small randomized study, the average is about 0.23. A large quasi experiment is 0.17, whereas the small quasi experiment is 0.33. Okay, I think we're almost, I think we're here. So, based on what we found, I think this is some of our recommendation. First, if you're conducting a research review or meta-analysis, making sure you search all the study, right, including great literature that will meet well-justified standards. Also, when you're conducting a experiment or educational evaluation, try use randomized trials whenever it's possible, and exclude. I don't mean to exclude, but it's possible. If possible, exclude researcher developed measures. Sometimes it's almost impossible, depending on what kind of research you're conducting. But if you look at the result we found, is almost double the effect size. And also sometimes it's difficult. You have a small scale study. I think maybe it's a good idea to pull similar small scale study to build up sample size over time. Large randomized study is difficult, it's costly, but it's a way to validate promising programs. I think Steve will talk about this later on. So the conclusion is, I think evidence-based reform has great potential to improve the quality of programs students receive, and to feel much interest and investment in development, research, and dissemination of effective approaches. However, evidence-based policy will prevail only if the evidence itself is rigorous and meaningful. Thank you.
What we're going to do is we will go ahead and switch speakers and do all the questions at the end to make sure we get both speakers in. And then I'm going to also read a biography for Dr. Ross. So if you want to go ahead and get his screen going, we can do that. And so while they're doing that, I'm going to introduce to you our second speaker, Dr. Stephen M. Ross. He is a senior research scientist, professor, and director for the Center and Reform in Education at Johns Hopkins University. His current projects include the evaluation of principal preparation and professional development programs, a citywide turnaround initiative in Syracuse and Buffalo, and after-school mentoring and experiential learning programs for children and adolescents in multiple states. He's the author of 6 textbooks and over 140 journal articles in the area of educational technology, at-risk learners, educational reform, extended learning time programs, and research and evaluation. He is editor emeritus of the research section of the Educational Technology Research and Developmental Journal, and a member of the editorial board for 4 other professional journals. He has testified on school restructuring research before the U.S. House of Representatives Subcommittee on Early Childhood, Youth, and Families, and has been a consultant to the National Science Foundation on project evaluation design, and is a technical advisor and researcher on current federal and state initiatives regarding the evaluation of out-of-school learning, technology, usage evaluation of principals, and supplemental educational services. So thank you and welcome, Dr. Ross. And we could have used your tech skills as we navigated some of our issues. Anyway, thank you so much for presenting.
Okay, I think I'm off mute and you can hear me at this point. I'm going to be talking about disseminating evidence to consumers, advancement, challenges, and benefits. My colleague at Johns Hopkins, long-term friend, Alan Chung, just went through a lot of good information about what impacts effect sizes, but ultimately, all of us in the educational research field know that the benefits of what we do depend upon reaching consumers so that we can make a difference in schools. Back in the 1600s, a mathematician, a well-known mathematician in those days, Pascal, indicated that people almost invariably arrive at their beliefs, not on the basis of proof, but on the basis of what they find attractive. What I find interesting and a little discouraging at times, but it's reality, this is a mathematician talking, an individual that deals with numbers. Yet he realized that the numbers didn't always convey the same things to everybody who consumed them. And that's a challenge we have in educational research. How can we take the volumes of information that we collect about what programs work and how they work and get them to the teachers and principals who work in the school? We've come a long way. We're not there yet, but we'll talk about some of the events that's happened and some of the things that we're doing at Johns Hopkins to make evidence more accessible and used, and also what's happening nationally and internationally in that regard. Some of the events that have occurred over time, over the last 2 decades, the No Child Left Behind. We could talk about a lot of aspects of the No Child Left Behind Act that were not favored by practitioners in terms of putting way too much emphasis on achievement testing. But the No Child Left Behind Act in 2001 also did a service to the field by promoting randomized control trials and rigorous research. Randomized control trials were called the gold standard. And the NCLB Act put the gold standard or made it more prominent in terms of saying to the field, we need to study phenomena more rigorously. Standardized testing scores as evidence of school effectiveness became more prominent. There are many people in the field, particularly practitioners, that would say that was not a good effect, but it still brought standardized testing to the fore as a way of being able to assess interventions that we're researching. In 2003, the What Works Clearinghouse was formed. And the What Works Clearinghouse was developed as a means of disseminating information to consumers about what works. And the What Works Clearinghouse can't do it all. They review only a limited number of studies each year. I think it's in the neighborhood of 15 to 20 in an entire year. And it takes a while to get these published. But their purpose still was well formulated in the sense that the public, particularly practitioners, schools, and teachers, need to know what works and what has been thoroughly researched. The What Works Clearinghouse has 2 main categories: evidence that meets standards without reservations, and here at Texas A&M, they know that category well because on nearly all of the interventions they test, they strive for that, to have a study that achieves evidence without reservations, and that's a randomized trial. In order to reach that category, an RCT is needed. But there's many quasi-experiments that are done, and that's still a very prominent level of evidence, but the What Works Clearinghouse labels that reaching standards with reservations. It actually sounds worse than it is with reservation, but in the real world, oftentimes we can't randomly assign programs to people in schools. So with reservations also has a touch of reality to it, which makes it a good category as well. In 2015, we really began to elevate the prominence of evidence in education and made both vendors, those who develop programs, and users, school districts, more aware of it. The Every Child Succeeds Act developed 4 tiers of evidence, and these are very vital today, used very much so. If you develop a new program and school districts are considering it, probably they will ask, do you have evidence? And at what tier? Can you show us the proof? Tier 1 is nearly identical to the What Works Clearinghouse without reservations. It's a randomized experiment. Tier 2 is similar to the with reservations, a quasi-experiment. Tier 3 is promising evidence, and it's more correlational. Actually, at Johns Hopkins, we kind of refer to Tier 3 as a weaker Tier 2 study, a Tier 2 study that probably doesn't have a control group that's quite as well matched to the intervention group as it should be. But still, that's a good start. And for newer programs which haven't had a chance to obtain higher level evidence, there's Tier 4, where you can show a logic model, a rationale, a research base. Those of you who write federal grants always come across a section that says, why are you doing what you're doing? What's the theoretical basis? What's the logic model? So these 4 tiers, especially the first 3, 1, 2, and 3, are very likely to get the door open in states and school districts for using particular interventions. But do they use interventions? Do they use evidence? Do they read the articles we spend so much time writing and actually make use of them? Well, we're about to find out what we found out, but we'll get to that in a little bit. Dissemination of evidence is increasing. I mentioned the What Works Clearinghouse. We at Johns Hopkins have the Evidence for ESSA website, and I'll give you a link for that at the end of this presentation so you can check it out. But the Evidence for ESSA website is not an official government dissemination tool, but it's one that we use and maintain as a service. Unlike the WWC, which reviews maybe 15 studies a year, we review upwards of 100 a year. We review them as they come in, and we publish them. We disseminate them a couple of months after we review them. So we're trying to provide more of a Consumer Reports quick turnaround. Of course, there's the journal and Best Evidence in Brief, the Best Evidence Encyclopedia, a whole bunch of dissemination resources that didn't exist 10 or 15 years ago. And on the positive side, practitioners are much more actively seeking evidence on programs than they ever have, but they're not doing it enough, as we'll describe in a bit. States and school districts are increasingly request evidence support from program developers. I mentioned that earlier. As an example, you may want to have a program adopted in Texas, a reading program. And the state may say, before we'll let you do that, we want to see at least Tier 4 evidence, but we prefer Tier 3. Send us a link to the study. We'll make sure that you're ready to go. But if you don't have it, you're on hold with that intervention. We can't approve using that intervention with federal dollars or maybe even state dollars. So developers and vendors, and this is good, are increasingly requesting research studies or initiating them on their products. And Alan mentioned a few things, a few factors that can artificially increase effect sizes and significance, like using developer-made assessments. Can't do that anymore. If you use your own assessment, the What Works Clearinghouse isn't going to take you. Evidence for ESSA isn't going to take you. So we are elevating the field gradually, but a lot's been accomplished. A few years ago, Jennifer Morrison, myself, and Dr. Alan Chung did a study on procurement, meaning how school districts acquire products. And we found there are 5 stages. Well, first you got to get the funding before you can buy a new reading program or math program. But once that's approved, generally more systematic school districts do an assessment of needs. What do we need? Is it reading? Is it math? Is it all of the above? What kind of program? And then this particular study looked at ed tech products, of which there are many nowadays. And the next step is to discover what products are available. But then the important step, the one in aqua, if that's the right color, I'm not big on many blues, but evaluation of products. How do you pick the one that you are going to procure and put into place? Are you going to pick it because of a nice marketing advertisement that looks really fancy, or a friend of yours that used it? Or are you going to read the journal articles that we've published, or the What Works Clearinghouse or Evidence for ESSA? Well, you're about to find out what they actually do. And then once you've evaluated the different products, you acquire them. So these are steps that should be done. They're not always done in an orderly or systematic fashion, but the more effective districts use this kind of approach, and most use it in one way or another. But the challenges, despite all the gains we've experienced in the past few years, as I've just described, consumers are still reluctant users of research reviews. They're not used to reading about effect sizes and about randomized control trials and joiners and attrition and those kind of constructs that we use in the educational research field. And meeting evidence criteria is more difficult for certain types of programs than for others. Think about that for a second, because we're going to spend a little bit of time on it. Why is getting evidence criteria harder for certain kinds of programs? Alan Chung mentioned a few of the factors, not so much involving programs, but involving the kinds of research designs that are used. Program effectiveness is defined differently by multiple stakeholders. Ask a kindergarten teacher what makes a literacy program effective, and she or he will tell you. But ask the teacher next door, and he or she will tell you something different. Each person has their own value judgments of what makes a program work for kids. And believe me, it's not based on effect sizes. If you go to the particular kindergarten class or even high school class, they will not mention effect sizes, I promise you. Complex interventions that are implemented in school districts are difficult to evaluate. The complex interventions that we evaluate in partnership with our Texas A&M friends are difficult to evaluate because they have many moving components to help schools. I'll give you an applied example of that in closing, of a big study we did in Baltimore County over a 5-year period, how complex that study was. Alan Chung already went over this. The concept of effect sizes have changed over the years, where what we used to consider a small effect size, 0.20, is now considered quite large. And for some programs, it's almost impossible to get an effect size of 0.20, a fifth of a standard deviation. So the effect sizes are much smaller than formerly believed. Therefore, it's difficult to get significant results. And you don't get into the What Works Clearinghouse or the Evidence for ESSA website if you don't have significant results, statistically significant results. And another challenge, and Alan spent a lot of time talking about effect sizes, and they are very important to we researchers who want our studies to get into the What Works Clearinghouse. But effect sizes are not meaningful to practitioners. I have a reference to an article you can read in the Educational Researcher, 2021. It won't surprise you. Practitioners like teachers don't know what effect sizes are. They're not impressed if you say we got an effect size of 0.30. They are much more impressed if they are told that this particular program produced an advantage of 3.4 months gain in achievement. They are impressed if you use a threshold type metric. 82% in the intervention group mastered the unit. Only 53% in the control group mastered it. Or they're even impressed if you tell them the actual scores. In the experimental group, the percent correct was 86% on the achievement test. In the control group, it was only 69%. Oh, I get that. I like that program. I'm going to buy it. So there are challenges. Alan Chung spent a lot of time talking about this, but large-scale randomized control trials cost a lot of money, and they take a lot of effort to do. I have colleagues here who can talk all about that for days, but they're often uninformative. It says my internet connection is unstable, but let's assume it'll go. Large-scale RCTs that involve 60 school districts, 200 schools, are often very uninformative because we can't herd all those cats out there. A lot of them signed up for the study, and then when it's time to do the intervention, they forgot they were even in the study, or they're too busy, and we're not getting quality type implementation. In this educational researcher article that I have up on the screen, if you want to read it, the average effect size was only 6/100ths of a standard deviation. Maybe it was statistically significant, but it's not telling you a lot about the power or the meaningfulness of the result. And I could talk for hours, which we don't have, about randomized control trials maybe being the gold standard, but also driving practitioners a bit crazy and maybe not always being realistic in terms of how you pick treatments. Schools and teachers often pick programs because they like them, not because a coin flip has come up heads or tails. So there's issues there, but that's for another day. RCTs are shown, the information we have on them are biased toward large schools and large urban districts. Here in Texas, a lot of the studies we work on are with very needy rural schools who don't have all the resources that Dallas or San Antonio or Houston might have. But if you want to read about what works, it's based on a study done in Chicago, in Los Angeles Unified, in bigger places that may not apply to what's happening at a small school that has one teacher per grade. And I have that bullet there that findings may not generalize to smaller districts. This one, Texas A&M has actually become, maybe become famous for. I call it the Texas A&M challenge. And it is that no results can be important, but evidence reviews have no place for no results. Like, what if you compare two treatments? A treatment that uses technology because you want to save schools time where they can't reach all the kids. Their teachers have too many things to do. And the other treatment uses class time, not technology. What happens if you find that they are both equal in terms of achievement? Is that important to know? Well, the What Works Clearinghouse used to say until last week that a study like that has no place because you have to have one is better than another. But suppose you find out that the technology treatment and the in-class treatment are equal. That suggests that you can use technology to free up your teachers for other things. Or if you don't have enough teachers in a rural school, the technology can help serve the purpose, but no place for that. Well, we have a study going here that was very similar to what I just described. And the What Works Clearinghouse originally said, but there's no place for that. But then they realized that the proposal was accepted because it was a very good proposal to discover, does technology make a difference, and so on. So they've changed their policy, and now comparing the two is important, and they have a place. We've also found in research that exact replications of findings are very rare. If I do a study in one district and I get effect size of 0.10, and I do it in another district, Alan talked about this, you're going to almost get an effect size of something totally different. Why? Because the conditions are different. The climate is different. The buy-in is different. the implementation is different. So there's not an effect size that's like something in chemistry that's like a half-life of an element. Effect sizes change from place to place. When we did our study of procurement, we found that the most frequent place that practitioners went to was not the What Works Clearinghouse or Evidence for ESSA or the journals. It was getting recommendations from peers. What works in your district? What do you like? The second most was doing their own pilots, which is good, pilot tryouts, or getting recommendations from teachers. But 81% said they did use rigorous evaluation evidence to some extent. And this study was done 3 years ago. I would bet, actually 4 years ago, I would bet that it's more up to like 85%. So things are changing for the better. But it's not an even playing field for programs. Not all programs or services have the same chance of making it to the What Works Clearinghouse or to the Evidence for ESSA website. It's unfair. It's a baseball game where one team has 1 inning, I'll use your metaphor, Alan, versus a baseball game where the other team has 11 innings in which to score. And we need to understand that. Core curricular programs in reading, math, and science that are used every day as the main program have a much better chance of getting big effect sizes than smaller programs. Programs that target student achievement have a much better chance of getting effects than programs that target classroom management or social emotional learning. Those programs are hard to measure the effects. And some programs have the opportunity for large-scale research. Others are more esoteric. It's hard, like we're working at Hopkins with a program, about to work with one that deals with debate, school debate. That's not a big seller, but it's important. But it's really hard to do a large-scale study on school debate. Programs that are evaluated by an efficacy standard or orientation versus effectiveness. Now, you're probably getting tired listening to all this lecture, but in the literature, an efficacy study is a study where an intervention is examined under ideal conditions. It's not cheating to put in the A team of professional development and say, let's give this the best chance to break through. An effectiveness study says, no go. You need to do it realistically. You shouldn't be sending in the A team. Stay away from it. Once it's launched, you stay out of it if you're the developer. But obviously, an efficacy study has a better chance of getting results than an effectiveness study. And Alan Chung mentioned this. If programs most able to get evidence effects are evaluated in comparison to a weak control group. If you want to win the horse race, run against the slow horse. That's the best way to come through first. And the What Works Clearinghouse isn't going to necessarily catch you on that. So there's not anything that you'll read in the What Works Clearinghouse or even in Evidence for ESSA that says you have to have a control group that is doing a strong program. So there are ways that effect sizes can definitely be changed. Now, which programs are least able to get evidence criteria? And I don't feel badly for these programs, but I feel like I need, as an evaluator, to make my best effort to get them onto the board, because they're the ones that only get 1 inning to score. They're the ones that are running uphill, where the other groups are running downhill. Supplemental programs. Schools use many supplemental programs that are 15 minutes a day, 40 minutes a day, 30 hours total. These are valuable programs. They free up teachers as kids are doing like tutorial in math or science. They often raise students' motivation, and they often raise achievement, but not to the same extent as a core program that's used every day. As the converse of what I mentioned before, programs that are not targeting student achievement, like school climate, social emotional learning, student behavior, it's harder to get measures on those that have big effects. Complex programs, systemic initiatives are harder to get effect size because there's so many things happening. Programs that are evaluated in comparison to a strong control group. You want to lose a race? Race against a fast horse. Programs with small or even zero effect sizes. Wait, why would we even be considering that? Suppose that in a school we use, this is similar to the example I gave you before. Suppose we use a virtual teacher. Here in Texas, we actually have a teacher from Utah that's teaching our kids that's on Zoom to replace a regular teacher. Should the Zoom teacher get better effects than the regular teacher? I don't think so, but suppose the Zoom teacher is similar to the regular teacher. That's useful because the regular teacher's on leave. So we aren't expecting a big effect size. And similarly, an ed tech program that's used up to free up teachers for other tests. So the questions we would want to ask in terms of what makes a good program, one that you can trust. Has the program demonstrated effectiveness in rigorous studies? Sure. Are they on the website? How many studies though? Has it just been one, a few, many? We're more likely to trust the program that's been evaluated more frequently. When were the studies conducted? Like studies that are in the What Works Clearinghouse may have been conducted even on evidence for ESSA 20 years ago. Well, that was fine, but federal policies have changed, teachers have changed, schools have changed. We need more modern stuff because the conditions are different now. And what is the meaning and importance of the effect reported? That's an important question. Did the studies take place in context similar to our schools? Practitioners want to know that. I mentioned that. If you're a rural school and you're reading about a study that was done in a big urban district, maybe that doesn't pertain to us. How demanding is it to implement the program? I like the fact that it has a big effect size or it's moved the needle on test scores. But does this take a lot of work to do? Did teachers like it? Or did they say it was hard to do and it was really different from the way they were trained and kids didn't seem to like it? Is it very costly? Like maybe it has a very good effect, but implementing this program would mean we couldn't do 4 others that are almost as good by adopting a program that was almost as good. So there's a lot of questions consumers ask. We have tried at Johns Hopkins, as I mentioned early in this presentation, to provide consumer-friendly evidence. So those of you who can see the screen, the website for the Evidence for ESSA website, you can get on it and very quickly look at examples of many studies in different areas. We're expanding the website to include, we've recently added science, we'll be adding social emotional learning, and not only having quantitative information about statistical significance and effect sizes, we're going to be adding qualitative information indicating what teachers said about it or students said about it so that consumers can see more about the program, including cost. So check it out when you get a chance. I would now like to quickly just go through an example. I'll try not to be very long on this because I know you've been listening a long time. But I just wanted to show that there are many faces of program effectiveness. Remember the question we asked early in my presentation. What makes a program effective? It really depends upon your point of view, doesn't it? What you're looking for in a program. We did a 5-year study as evaluators in Baltimore County of technology integration. The initiative was called Students and Teachers Accessing Tomorrow, STAT. You can look it up if you're interested in reading more about it in detail. We can send you a technical report that's more than you want to read, but it'll have all the detail. It was in a big school district, over 100,000 students. We were the evaluators. Let's see. I'll give you kind of the logic model all at once. The inputs were professional development to administrators, the staff teachers, classroom teachers, coaches. Measurable outcomes. Remember, this is technology integration, using technology to upgrade the quality of learning, more student-centered learning, more active learning, more 21st century learning, if that makes sense. So there should have been changes in classroom environment, what you saw when you walked into a room, teacher practices, digital content, how resources were used online that helped teachers. And we would expect students to show greater engagement and 21st century skills. And of course, the longer term goals were student achievement, equitable access to technology. That's important. Kids that come from lower income areas don't have as much access to technology. So this initiative was about equity as well as student achievement and developing globally competitive students. That was a very important goal. Students that when they graduate, they could go into a business and know how to use technology or go into a career and be fluent in it. So this was a complex initiative with many moving parts, and we did it all in terms of observing classrooms, interviews, surveys, looking at student achievements. So what were the key findings? Really and truly, teachers liked it. They thought they were making changes. Students liked it. They enjoyed the more technology, the greater technology. Most parents did, principals did. Their implementation tended to get stronger and was moderate to strong despite the complexity. Students became frequent and strong users of technology. We could see that every year. We did many classroom observations. Pedagogy shifted from teachers lecturing to where you'd go into a class and students were working on projects and doing cooperative learning, even working individually. There was certainly some teacher presentations, but it was much more mixed. But some people on the school board said, we want to see changes in student achievement. It's all about student achievement. And we would be there saying, yes, but that takes time. And it's hard to move the needle on a standardized achievement test. The results were normative, meaning small effect sizes, but not showing large effect sizes, but yet the students were doing all these other kinds of things. So let me return to the quote by Pascal as I end and ask the question, did people think that this 5-year initiative, did stakeholders think this 5-year initiative was effective? Was this an effective intervention? People almost invariably arrive at their beliefs not on the basis of proof or evidence, but on the basis of what they find attractive. So, was this program effective? Most said yes, because of increased technological skills, equity of access, student interest and engagement. But there were a fair number saying, get rid of it. Achievement didn't go up, but the students are using technology. They're doing all these, achievement didn't go up. We don't want our students on screen time. They're going to go blind or their brains are going to fry. Screen time was too long. Or we want other priorities. We want to use the money to reduce class size or repair the schools. So despite the fact that 2/3 saw this as successful, there was 1/3 and quite a few parents that said, no, we want other things. It's hard to please all of the people all of the time in both politics and in education, and programs come and go. But I can tell you one thing, that although evidence is interpreted through many lenses and success by some is failure to others, and many confounding variables influence student achievement, If we hadn't been doing this research for 5 years, that initiative probably would have ended after 2 years. The evidence we were able to show kept it going, kept people seeing what was happening aside from student achievement. And it also helped the 2/3 to see what reasonable expectations were for teaching practices, for student engagement, for technology skills, and for student achievement. Otherwise, programs are thrown out often before they even have a chance to develop and grow. School leaders need to reinforce reasonable expectations and not promise outcomes. Developers, people who come up with new exciting programs, should not go into districts and say, student achievement's going to go up by 0.5 next year. Only say it if you've seen it and believe it. Indicate what the short-term effects are and the long-term effects, and you'll be telling them the truth. The evidence movement is already making a great difference, but consumers want comprehensive information, not only effects. They want to know effects, implementation needs, they want to know satisfaction, they want to know what is current information, they want to know costs. They want to know the big picture and the whole picture. So thank you.
All right. Thank you very much for the amazing presentations that we were just able to view, two very insightful conversations. And I do know that we have some questions. The first question is actually for Dr. Chung, and it's from Julia. She said that you shared some suggestions for properly looking into the effect sizes. Regarding one of them, what would be potential risks for excluding gray literature for meta-analysis or systematic reviews? Also, does it make any difference for studies without quasi-experimental designs or any interventions in social studies? Thank you in advance.
Okay, I catch the first one. Let me answer the first one though. I think it's important though, because there's some study being, published online or not, in the literature, especially, dissertation and thesis. I would consider those as unpublished or in the gray area. So I think it's important to include those, because excluding those, you're inflated, the overall effect size. And also, I think when we conduct, looking at the impact of a particular, program, we often contact those people, developers, right? Whether they have, any study that has not been published that we can use to be included. So I would say it is important to include those, great literature in the review. Otherwise, you'll get, all the good study, because, well, especially if you look at, review in the past, you're less likely to get, published if you get a, zero effect, right? But, right now with, especially when you got, money from the federal government, right? You have to publish, those results, at least online. So I think it's easier to look up those studies. So I would, say if you're doing a review, making sure include those studies. Yeah. But I didn't catch the second one though.
Okay, let me repeat that. It says, also, does it make any difference for studies without quasi-experimental designs, or experimental designs, or any interventions in social studies?
Well, as I showed, I think there's those studies using, quasi-experiments, they tend to have a larger, but not as, compared to the other features. But as Steve mentioned, right, sometimes it's just difficult to do a randomized study. And a lot of the, especially educational intervention, they will use, intact class and, just doing a quasi-experiment. Sometimes I think we did a study 10 years ago on educational technology. I mean, we have only, 5 schools versus 5 schools. Of course, we want to, analyze at the school level, but we just did not have enough sufficient, level 2 to conduct hierarchical linear modeling, multi-level modeling. So I think it's very, I think it's useful to include those, but making sure you look at, the effects of, those study with quasi experiment design versus those experimental design. So, but the gold standard is experimental design, but I wouldn't exclude those that are good, quasi, experiment studies.
All right, thank you. We have another question, and I believe based on the context, it would be for Dr. Ross. It's from Dr. Fernwald. It says, is there a disconnect between the increasing demands for research-based evidence of intervention program effectiveness and the de-emphasis on standardized testing outcomes as measures of equity and accountability? What are the implications of education reforms that favor non-standardized outcomes as measures of academic accountability?
Yeah, I mean, that's a very good question. And, as both of us have been talking about, it's very difficult to, get that kind of evidence that ESSA would favor. There would be tier 3 or tier 2 or tier 1 if you're going for equity. Obviously that's what we were trying. That was one of the very big goals of the Baltimore County STAT initiative. Equity was really big, and 21st century skills were really big, and that was hard to measure. So there is a disconnect in the sense that the studies that or the products or services that depend on standardized achievement measures, even progress monitoring, or especially progress monitoring like NWEA MAP or iReady or Renaissance Star or state tests, have a big advantage on getting in the charts. But what we try to do at Johns Hopkins, and we can't save every program, but where we can't, where there is an interest in something like equity and something that's more difficult to measure, we try to really help the developer with a very strong tier 4 portfolio, showing how what they're doing is leading to that. And with at least, if we can get a tier 3 type study showing some movement in terms of outcomes, like you could do a developer measure for tier 3 of ESSA. You can't do a developer-based measure for tier 2 or tier 1. So I probably spent too long answering the question, but yes, it is more challenging. There is a disconnect, and we just need to work harder to show a research portfolio for those kind of interventions.
Okay, so Dr. Irby has put in some information, but also a question. Often a school will dismiss a program after a semester without evidence, or just that they don't like it. Sometimes a school just does not listen to the findings of research. How would you suggest that we as professors could incorporate this type of learning in pre-service teacher education programs to get them aware early?
To get school districts aware? Oh, pre-service teachers.
Pre-service teachers as they take it with them when they become in-service teachers.
I mean, I have my own opinion. I mean, I'm a few years away from teaching those courses, because I've moved over to the research center. But I think that's really an important question. Like a lot of and Alan, you can chime in. I think a lot of pre-service teacher programs, we have the students take the research course. Sometimes we have them take the baby stat course, and they learn about research methods. And I actually used to teach that course to MAT type people when I was in Memphis. And yeah, they go through, we're learning about a type 1 error, type 2 error, like what research, what experiment is. But should they really, in that pre-service teacher experience, be learning more about the importance of evidence and how to use it, and how to make selections in their classroom, and how to work with their principal and school leadership team in when to keep a program, what are the important findings? So maybe we need to move away from the research methodology as much in those courses and more toward the consumerism. And that's just an idea that I had while we were talking. Alan?
Yeah, I think
Okay, I may follow up with that because I follow a lot of educator chats. And oftentimes they talk about what you mentioned, Dr. Ross, where a district will actually adopt some program, but educators who are actually informed about evidence look at it and wonder why they're being forced to employ this curriculum that may not have evidence. And so honestly, maybe there needs to be more of this also in principal preparation. I'm just curious what your
Oh,
thoughts are.
absolutely. Yes, principals and teachers and, school leadership really needs to know about that. So that should be in every school leadership course as well, and school leadership programs that principals would even have in service.
All right. Do we have any other questions? If anyone wants to unmute, you surely can. And so we can wrap this up, but we probably have time for one more question. Does anyone have anything they'd like to ask?
Yes, I do have a question. And first of all, thank you so much for the wonderful presentations, Dr. Chung and Dr. Rose. I mean, it's great. As a doctoral student, I'm so honored to hear your lectures. And I do have a kind of personal questions because I'm dealing with a chapter of my dissertation. In this study, I do have a standardized test and a researcher design test. And the standardized test, as you mentioned from the previous studies, that the effect size of this study results are comparatively smaller than the researcher design test. But I did not discuss too much about this difference. I just in my discussion part, I just talk about the whole study. Like I do have a significant result. Do you think it's necessary for me to address this difference between the standardized test and the research design test? If I do need to address this difference, shall I address this as a finding or address this as a limitation of my study design? Thank you.
You want to take it?
Yeah.
I mean, I'll say something.
Yeah. I would say, depending on what you want, but I would say, but what was the effect size for another measure? So is it pretty?
I'm sorry, what?
So what was the effect size of the other measures? Is it looking?
You mean this?
Yeah, you said you have two measures, right?
Yeah, there are a standardized test measure and a researcher design test measure.
Right. Yeah. What was the effect size for the other one?
For the standardized test is around 0.5, and for the researcher design test is like around 0.15.
0.15, yeah. Well, I will include them. I mean, this is important information, right? Because, some people will look at, well, overall, are you making a difference in the, general test? At least in Asia, right, we're concerned more about, whether you can make a difference in key stage 1 and key stage 2, those, standardized, outcome. Of course, we have to, making sure you're aware that, we're not going to, have a huge effect size on those standardized measures. But, personally, I will include them and then discuss it a little bit. Yeah. And the difference between the two.
And I definitely agree with that. And actually, I wouldn't call that a limitation of your study.
Right.
I would call that a strength of your study, because that is showing how the intervention you're using affects standardized and what to expect from that. But it also shows how it might affect a teacher-made test. So I think it's an asset of your study. Tell the story about both.
Great. Thank you so much.
All right. Thank you so much again for everybody being here. We appreciate our guest speakers coming and presenting this valuable information. So that concludes our presentation. I will be editing this out and working with it in order to get this out to everybody. So be looking for the email in the next couple of weeks so that you can have access to this and rewatch it and look at the slides again and all of that. So thank you again, and we wish you all the best for the rest of your summer.